We spent a couple of weeks now talking about position, displacement, distance, speed, velocity. We've really only learned one equation so far, right? V is equal to delta D over delta T. Now, V is equal to delta D over delta T could be used for speed, or if we added the little half arrow over top of it, we could make it for velocity. But it's essentially the same equation, right? We've done problems, including graphs, where it was constant velocity, uniform motion. Today we're going to start doing problems where it's not uniform motion, where we're accelerating. What does that mean if we're accelerating? We're speeding up or slowing down, or, anybody get this? Speeding up, slowing down, or changing direction. Remember, velocity is the rate of change of position. Acceleration is defined as the rate of change of velocity. Since it's the rate of change of velocity, it depends upon the change in velocity. And velocity is a vector, which means that the velocity changes if it speeds up. It means the velocity changes if it slows down. It means the velocity changes as it changes direction. So there's an acceleration whenever we have a change in speed and or a change in direction. Now, for this unit, we'll be dealing with speeding up and slowing down, not the change in direction for acceleration. But we will get to that 2 units down the road when we're changing direction. Call it circular motion. The symbol for acceleration is A with an arrow over top of it. That means that acceleration is a vector. The units for acceleration are meters per second squared. Sometimes people call it meters per second, which is correct, but it's kind of an odd way of writing it. So we usually just say meters per second squared. Right? It's meters per second velocity over time, so meters per second over seconds, which becomes meters per second squared. Now, you can have a positive value of acceleration or a negative value of acceleration. It's a little bit trickier here for the signs for acceleration than it is for velocity. If you have a positive velocity, it's going forward. A negative velocity is going backwards. End of story. A positive acceleration can occur in 2 situations. A positive acceleration occurs when you're speeding up in the positive direction. So in other words, you're speeding up as you're moving to the north, or you're speeding up as you're going to the east, or you're speeding up as you're going to the right, or you're speeding up in whatever direction you've defined as positive. That's a positive acceleration. You get a negative acceleration if you're slowing down in the positive direction. So if you're moving to the north, you're slowing down as you move to the north. Or you're moving to the east, but you're slowing down as you're moving to the east. That's a negative acceleration. Anybody want to take a stab at when we could, another situation where we could have a positive acceleration? Not speeding up in the positive direction, but rather slowing down in the negative direction. Yes. So an example of that would be I'm driving to Calgary, which is the positive direction, it's north. If I'm speeding up as I'm driving to Calgary, that would be a positive acceleration. If I'm driving back from Calgary, which is the negative direction, going south, and I'm slowing down, that would be a positive acceleration. When I drop my board marker and it hits the ground, it speeds up in the negative direction, right? But when it hits the ground, it slows down and stops as it moves in the negative direction. That's actually a positive acceleration. Not as it falls, but as it stops, that's a positive acceleration because it's slowing down in that negative direction. Now, we said an acceleration was negative when you slow down in the positive direction. You're going north, but slowing down. When else can it be negative? Sorry? Yeah, when you speed up in the negative direction. You're going south, but you're speeding up. You're going left, but you're speeding up. You're going whatever direction you've defined as negative, and you're speeding up. That's a negative acceleration. So to get a negative acceleration, it doesn't mean you're slowing down. It usually does, but not necessarily. It could mean speeding up. But it means if you're speeding up, it means you're speeding up in the negative direction. Now, acceleration can be anything from 0 meters per second squared to thousands of meters per second squared. If we drop an object or throw an object up into the air, and it's under the influence of just gravity, there's no air resistance, there's no anything else affecting it besides gravity, the acceleration will always be the same. There's a famous video of the astronauts that landed on the moon in 1969 dropping a hammer and dropping a feather right beside each other at the same time. Guess what? They both accelerated at exactly the same rate because there's no air resistance on the moon. In the absence of any other forces other than gravity, an object rising or falling on Earth, that is, will always experience an acceleration of, anybody know what that is? Negative what? 9.81. Good, negative 9.81. Now, does that count for rising and falling? When it's rising, shouldn't it be positive 9.81? What's happening to this object as I throw it up into the air and it's rising? It's slowing down in the positive direction. When you slow down in the positive direction, you get a negative acceleration, negative 9.81. What happens when it comes back down? It speeds up in the negative direction. We would call that a negative acceleration, speeding up in the negative direction. So regardless, if an object, whether it's going up or down, if the object is under the influence of just gravity, we're going to say its acceleration is given to us. It's negative 9.81 meters per second squared. Now, realistically, air resistance plays a factor, right? When we're on Earth, there's always going to be air resistance. But the problems that we'll do, air resistance will be small enough that we can avoid counting it. So we're just going to say A is negative 9.81 in most or all of those situations. All right. So we got a given sometimes, negative 9.81. But it still doesn't help us to solve a problem unless we have an equation to sub it into. Well, yesterday, well, until 2 minutes ago, you had one equation. D is equal to delta D over delta T. 2 minutes from now, you will have 6 equations. V equals delta D over delta T and 5 more that I'm about to give you. We're going to say that A, acceleration, is equal to delta V over delta T. That's the definition of acceleration, right? The rate of change of velocity. We're also going to say, for acceleration, delta D is equal to VIT plus 1/2 AT squared. Ooh, that's a long, ugly one. Try using the triangle for that, baby. D is equal to VIT plus 1/2 AT squared. How about this one? D is equal to VFT minus 1/2 AT squared. How about this one? D is equal to VI plus VF over 2 times T. How about this one? VF squared is equal to VI squared plus 2AD. Holy cow, are you kidding me? Yeah, I'll get you one second there. We go from one equation, v is equal to delta d over delta t, to 6 equations almost instantly. That's okay. Okay, that's okay. You just got to remember, and I'll get you, Marcos, I'll get your question in just a second here, okay? You just got to remember that v is equal to delta d over delta t applies when you have constant or average velocity. These equations apply when you have acceleration. We're going to call our v is equal to delta d over delta t equation our group A equation. We're not going to use this when we have acceleration. We're only going to use that when we have constant velocity. Group A is when we have constant or average velocity. We're going to call these ones, our new ones, our group B equations. We're going to use our group B equations when we have an acceleration, speeding up or slowing down. Whenever we see a problem now, it's not going to be good enough to just write down givens and then sub it into v is equal to delta d over delta t. Now, when we see a problem, we first, before we even write down givens, we're first going to identify whether it's group A or group B. If it involves constant or average velocity, we're going to say group A and go directly to v is equal to delta d over delta t. If it involves speeding up or slowing down, we're going to call it a group B problem and then use one of these other 5 equations. Once we've identified group A or group B, then we'll write down our givens. And if it's group B, we'll use our givens to determine which equation we want to use. Here's the good news. As long as you're using the right category of equations, you've identified group A or group B correctly, you have nothing to worry about in terms of trying to find the right equation. Let's say I got a group B problem, and I want to use, and I say, oh, I think it's the second equation I should use. If I try the second equation and it doesn't work, like it's not the right equation to use, you're not going to get the wrong answer. You're just not going to get an answer. You're going to end up with 2 or 3 unknowns and you're not going to be able to solve it. What should you do if that happens? Try another one. You got 5 options, right? If it's a group B problem, you got 5 options. You never have to worry about picking the wrong option. If you pick one that doesn't work, that's okay. You'll find that out. You'll discover that. Pick another one. If that one doesn't work, that's okay. Pick another one. Worst case scenario is you burn up some time picking all these different equations, but you're not going to get the wrong answer unless you pick from the wrong category. Right? If it's a group B problem and I pick a group A equation, then I might get the wrong answer. Or if it's group A and I pick group B, then I might get the wrong answer. But as long as you're picking from the right category, you're not going to get the wrong answer, even if it takes you 5 guesses, we'll call them, to get the right equation. Let's just do one example and then we'll call it a day. Example number 8 in your booklet says a car traveling at 10 meters per second accelerates to get past another car. If it speeds up to a velocity of 25 meters per second in a time of 6 seconds, what's the acceleration of the car? Remember what we got to do now every single time. Not write down our givens first. Givens are important, but something else is more important, and that is understanding the situation. Is this group A or group B? Remember, group A is constant or average velocity. Group B is acceleration, speeding up or slowing down. Is this group A or is this group B? It is definitely B. Yep. We're speeding up here, right? We're going from 10 meters per second, 25 meters per second. We're speeding up. So it's group B. We've identified it's group B. You may want to write that down or not. You might just want to keep it in your head. That's okay. Now we write down our givens after we've identified what's going on in this situation. So let's do that now. Let's say that, well, something is 10 meters per second. What is that? Something else is 25. Wait a second. How do we have 2 velocities? Let's call the first one VI, and let's call the second one VF. The initial velocity, the final velocity. I got a time interval of 6.0 seconds, and I'm looking for the acceleration here. Now remember, we've got 5 equations that are available to us right now. The only equation that we've learned so far that's not available to me is my group A equation. I am not allowed to use V is equal to delta D over delta T here. The only one we've ever used, we're not allowed to use here. The other 5 equations, I am. Remember, I've got VI, I've got VF, and I've got T. Some of you are going to be really good at finding the right equation to use right away, and that's wonderful. Some of you aren't. That's okay too. It's just going to take you a little bit more time to do it. Does anybody see one of these equations here that might match up pretty good with what I have given to me here? VI, VF, and delta T, looking for A. Nick? Okay, good, Nick. D is equal to VFT minus 1/2 AT squared. Thank you, Nick. Now, Nick didn't say VFT minus 1/2 AT squared, but I was kind of hoping he would say something like this. Why? Because it's a valid equation. I want to demonstrate for you when you pick a valid equation, it may not lead you to the answer, but it's not going to give you the wrong answer, right? Nick gave me the one that I would have used. A is equal to delta V over delta T. That's absolutely the one that I would have started with. But there's nothing wrong with trying to start with this one. And I'm going to show you that. D, oh, I don't know what D is. VF, okay, I got that. T, I got that. A, I don't know what that is. T, I got that. That's 2 unknowns, isn't it? Can you solve for T when you have for A when you have 2 unknowns? No. Did it give you the wrong answer? You can't get the wrong answer here. You can't solve for anything. Try rearranging this. Go ahead. Rearrange it. Try solving for something. You can't solve for anything. So when you look at this, say, oh, I can't get the answer. What do? You try something else. Don't pout because you got a wrong answer. You didn't get a wrong answer. Don't pout because you didn't get an answer. Try another equation. The one that Nick gave us, probably. Although in the end, if it took us 5 times to get around to this equation, that would be okay. It just means it took you 5 times longer to solve the question. All right, we're looking for A here. Delta V is VF minus VI, so we're going to say 25 minus 10 over the time interval of 6.0 seconds. 25 minus 10 is 15. Divided by 6.0 meters per second, that's going to give us 2.5 meters per second squared. Now, if I look at my original data, you can see that this is 2 digits, this is 2 digits, this is 2 digits. My final answer should be 2 digits, and sure enough it is. How many people were thinking A is equal to delta V over delta T? How many people had no idea which one to try first? That's okay. That's okay. As long as you don't try V is equal to delta D over delta T, pick one. Go with it. Doesn't work? Pick another one. Doesn't work? Pick another one. The worst that's going to happen is you go through 5 of them and the last one's going to work for you. Got it?